So we have a plane flying horizontally. The altitude is 1 mile. So think of that as the height. And the speed of the plane is 420 miles per hour. And it's flying over a radar station. So we'll say the radar station is over here. And we'll label the hypotenuse D. That's the distance between the plane and the radar station. So we want to find the rate at which the distance from the plane to the station is increasing when it is 2 miles away from the station. So the rate here refers to the derivative. So we're looking at the derivative of the distance with respect to time. So this is what we need to solve when the distance is 2. Okay, so here the distance is 2. So I can actually solve this right triangle by using the Pythagorean theorem. And we would get that the base of the triangle is square root 3. And this is, of course, in miles. Okay. So in order to find the derivative of the distance with respect to time, I need to use a Pythagorean theorem. So I'm going to label the base b, the altitude h. So I'm going to have b squared plus h squared equals d squared by the Pythagorean theorem. And then if I take the derivative of both sides now with respect to t, because that's the independent variable, so I'm going to get 2b times db over dt plus 2h times dh over dt equals 2d times the derivative of d with respect to t. Okay. So now it's just a matter of plugging things in. Okay, so 2b, b is the length of the base. So we said that is root 3, so it's 2 times root 3. db over dt is how fast the horizontal distance is changing. Well, the plane we said is going 420 miles per hour. The height is the altitude here, which is 1 mile. And the height here is not changing, right? Because the plane is only moving horizontally. It's not moving up or down. So that's just going to be 0. And d, the distance, we said is 2. And then we need to find the derivative. Okay, so that's really, let's see, 840 root 3 is equal to 4 times the derivative of d with respect to t. So we just need to do a little simplifying. So let's see, it's 840 divided by 4 is 210. Root 3 is the derivative of d with respect to t. And let's see if we round this. So that's 363.73. Okay, so that's miles per hour, okay, because it's a derivative, it's a rate. But our answer wanted to the nearest whole number, so actually we should change this to 364. So 364 really should be the answer. Okay. Now for the second question, we have two cars started moving from the same point. So we'll say this is the point. One moves to the west at 48 miles per hour. The other moves south at 64 miles per hour. And we'll say the distance is d between the two cars. So I'm going to label it just like the last problem. So the base and the height. So we want to see the rate at which the distance between the two cars is increasing 4 hours later. Okay, so let's look at 4 hours later. Okay, so if I'm going 48 miles per hour, in 4 hours, I'll go 48 times 4 miles, which is 192. So this is 192. Now the other car goes south 64 miles per hour, so that's 64 times 4, which is 256. And We make a nice right triangle. So here we can just apply the Pythagorean theorem, and we do get a nice number of 320. Okay, so because we want to find the derivative, we have to get an equation, and we're going to use the Pythagorean theorem for this. So we have b squared plus h squared equals d squared. Take the derivative with respect to t. Okay. So now we just plug in. Okay, so b is 192, and then the rate at which b is moving is 48 miles per hour. H is 256, and it's moving at 64 miles per hour. D, we said, is 320. And let's see. And then we're going to multiply that by the derivative of d with respect to t. Okay, so here we have to simplify. We can get rid of the 2's. And let's see. So we have to multiply 192 with 48, and then add that with 256 times 64. We do get 256 or 25,600 on the left is equal to 320 times the derivative of d with respect to t. So divide that and get 80. Okay, so the derivative is 80. So this is 80 miles per hour. So the distance is increasing at 80 miles per hour. Okay, so that is our final answer.